Right, so we're back with the Sony TA-4650, waiting on components to arrive, so I'm going to start tackling some loose ends like the speaker terminals, which we've got to replace. I also want to have a look at these RCA connectors because these are just stupidly loose and see if I can come up with something better. I'm not going to replace all of them because there's a stupid amount of them on here, but I want to at least replace the pre-out and main in terminals because that's where the main signal path resides, and maybe do the auxiliary inputs or something. We'll see what happens. We've also got to tackle the capacitors a little bit because the new ones are smaller in diameter than these ones, so they're going to require adapters also. This is going to be more around 3D printing and what is involved in replacing various parts that you have to retrofit into old amplifiers. These are the original speaker terminals that I've taken out. They're sort of like those push pin bare wire terminals, which I really don't like. There's a lot of potential here because the openings are so small that you'll try to shove a large set of wires in. You might have a wire hanging off and short out on the terminal next to it and blow the amp. I normally will sit it in there and I'll just check for free play to start off with to get some initial dimensions. And this is a nice little fit in here, so I'll take this out. I will take measurements off this, checking the hole spacing for mounting it and everything, and that will become the basis for the adapter plate I will make for new speaker terminals. You need a good set of calipers. Well, they don't have to be really good, but I always use good stuff, so Mitutoyo is what I use. In regards to what we are replacing these with, they will be replaced with banana sockets. I like these because they fit a wide variety of applications. The chassis protrusion internally is really, really shallow, so it stays well clear of power supplies and whatnot. Some sort of binding posts you buy have these massive threads on them, and you're just getting really close to things you do not want to be near. The other thing also is I do not use knurled binding posts that accept bare wires, similar to this if you ignore the banana section like that, because customers tend to over tighten them and strip them, and then they come loose and they can wander around in the chassis and short out and things can just go wrong. At the end of the day, in this day and age, all you really need is the banana sockets, and then you can plug whatever the hell you want into them. These will be press fit into the adapters I make, so they'll be incredibly solid. They will not budge at all, and they cannot be torn out or messed with or come loose. And if you want bare wires still, you can still get these banana plugs that accept bare wires, and then you just tighten them down and then they go into these sockets. And that's how I do things these days because I want things to be really reliable, and I find I cannot trust people not to short out terminals, blow up the amplifier, and then you get the blame for it. So that is why I don't go down that road anymore, and I think simpler is better. Yes, I know these aren't gold plated. It does not matter when it comes to speaker terminals. Sure, I like gold and I will use it if the cost difference is minimal. I'm not paying $20, $30 a binding post, and then you got to put 8 of them on an amplifier like this. It gets absolutely insane when you start adding up how expensive gold-plated stuff is. At the end of the day, it's basically audiophile jewelry. Yes, it does give you some benefits around oxidization and whatnot, but the reality is it's not going to affect the actual sound quality of the amplifier. And that's all there is to it. So I'm going to start sketching this out, and then I'll show you how I do a design, print it, and what we end up with. All right, so I've done a bit of work and I've got the final design, and I'm going to take you through it from the ground up. I know a lot of people use different programs for designing this stuff. You can use SolidWorks, whatever floats your boat. I actually just use Tinkercad a lot of the times because it's just simple and I can knock out a design reasonably quickly. The only area I find this program struggles with is when it comes down to aligning holes, making sure that they're all symmetrical and they're centered correctly. It doesn't have the best tools in regards to alignment, and sometimes you have to work things out manually. Just keep that in mind. But Tinkercad most certainly will get the job done for most of the work I have to do, and you can be quite inventive with the designs you come up with. So we basically start with the base plate. This is what's going to sit behind the rear metal chassis. I basically copied this directly dimensionally. No changes there. Everything's identical. We then add in the next layer, which is going to go through the cutout in the rear plate. This is again dimensionally identical. I did make the stack of these a little bit thicker than what we had before, just to accommodate the sockets that are going to go through. We then add in the mounting holes, which will hold this to the rear chassis. They were originally 3.5 millimeters for those push pin plastic retention plugs, which I absolutely hate. So I've reduced these to 3 millimeters for M3 screws with nylock nuts. You always want to use something that has either Starlock washers or nylock nuts to make sure they can never work their way loose, and this will be a lot more robust and it's not going to pop out or come loose in the future. We then add in the binding sockets, like these are the bushings that are colored, so you got red and black. The metal bit goes in those and seats in there. They don't go all the way through, they only recess down about 4 millimeters, and then the metal socket or shaft goes down through those. So then we end up adding another hole on the inside of that, which goes all the way through the other end. So it's like a 2-stage hole, but the larger section only goes down about 4 millimeters to accommodate that outer bushing, which identifies the socket, you know, so red or black, and it also gives it a bit more support as well. I decided to take this design a little bit further. In previous amps, this is all I've done. But in this case, I decided to add dividers between all of them also to make it extra idiot-proof, to stop banana plugs from shorting out on each other, which is why I decided to add these walls between each of them. And I've sized these quite good. I've done a couple of iterations of these, and I decided on the final thickness, which was 2.5 millimeters. For the material we're going to be using, which is Mark Forged Onyx carbon fiber material. This is really rigid and it works really well. I then added some nice little rounding on top so we don't have any sharp edges for people to cut themselves on. And this is what I came up with for my final design. Once we've done all that, we then just mesh it all together and we end up with our final design. So you can see that stepped section that the plastic bushing for those banana sockets will go into. They sort of seat in there, and then the metal shaft goes right through the entire design. So yeah, I am going to send this to my Snapmaker Artisan 3D printer. We're going to be printing in Mark Forged Onyx filament, and let's see what we end up with. So here is the finished result. I've already pressed all the sockets into this one and it came out really well. This is really, really rigid. The dividers are nice and strong. Nothing's going to break off. I've already tightened it down and everything. I've still got one left I've got to press all the sockets into, which I'll show you how I do that. This is press fit. That you cannot just get these in by hand. It takes a little bit of effort. And the reason why I don't usually do binding posts for people is because this is all the iterations I went through just to make these. And it does take quite a bit of time and trial and error. This one was done in PLA early on. PLA is quite good as well. It just doesn't have very good temperature rating and it won't hold up to excessive temperatures, unlike this onyx filament, which will take a lot of heat without deforming. So yeah, going to get these finished up, mount all the sockets in this one, and then let's get these installed in the amplifier. All right, so the banana terminal, speaker terminals are installed. Done everything as best as I can. I can already hear people saying I should solder directly onto the sockets, and look, I can do that. My soldering iron does have the capability and the power to solder like wires directly onto large pieces of metal like this, but it just isn't worth messing around with, because if I do this I can never back the nuts out again because the solder will be in the threads, and the heating and expansion does tend to loosen these things up again, and it just creates a lot more problems. So my solution is I tighten down the first set of nuts to retain these as much as possible. I put on the wire ring connectors, whatever you want to call them, then I put on the second set of nuts, and then I push these up into that second nut, which stops it from loosening again because it's applying pressure to it. The mounting bolts have the nylock nuts fitted, and these things are solid. Like, I am pressing as hard as I can and these things will not budge. The old terminals, I could actually make these flex and push into the chassis. I don't know if you can see it on these ones, but yeah, the old ones are crap, and these are insanely solid, way better than factory. They certainly look the part also. Anyway, I'm going to tackle the power supply caps next. We have to come up with a new way of mounting these, which have to go on this chassis. So let's tackle that now. These are the new main filter capacitors. They are a different size from the original, so they're about 36 millimeter diameter, roughly. The old ones are 40s, and we need to come up with something that will fit these capacitors in this holder. And I'm not exactly sure how I am going to do this yet. I did contemplate just 3D printing an entire new bracket, which is doable, or do I make some spaces to go between these and around the perimeter to take up that gap so this holder can still be used? I'm not exactly sure yet. I'm going to go off camera and have a ponder about how I'm going to make this happen, and we'll come back and I'll show you the results, but I just wanted to give you an idea of what we're actually dealing with here. I did have to open up these holes a little bit so these capacitors would fit and actually mount to the board. There's no issues there, but we still have to close this gap up and figure something out. Basically, how I ended up doing this was I took the original dimensions of the original capacitors in the length and the width, and then I decided to build the new capacitor holder around the diameter of the new one. So what I did is I screwed the two capacitors into the PCB, and I took a measurement between the two capacitors, which was around 10 millimeters. And I just sort of hoped and prayed that that was going to be what I ended up doing. So here is how I designed it in Tinkercad. You can't really do sort of a rounded rectangle sort of shape. You end up with an oval, so you have to do this as two half circles. Then you add a rectangular box in between. This is the only way I've been able to work out how to do this in Tinkercad anyway. Then I would join all this together and form that solid shape. And if you imagine what that retaining ring looks like with the two capacitors, this is basically the overall dimension of that. I then added in the two sort of cutouts for the Kemet capacitors. And this is the diameter of those capacitors, which will slot down into the holder. From there, I took a couple of cutouts. This was to save material, but also to give the holder a bit of flex to clamp down on those new capacitors. And the final part of the puzzle was to add in cutouts on each section. And this is what I ended up with. Yeah, so I printed this out on the Artisan, and as you can see, the fit is absolutely perfect. So that's another piece of the puzzle solved. Here's the final print. Like I said, the idea is that these will press in as you tighten down the screws on this bracket, so they will push down together. That's why you don't want this thing to just be a solid ring. You actually do need to grip the capacitors, not just hold them. And the whole thing will drop in like that. And then the power supply main filter caps will mount in the whole thing like this. And that is it. That went really well. And actually that wasn't as hard as I expected it to be. Probably the RCA connectors are going to be the worst part about this restoration. And speaking of those, let's tackle that last problem that we need to deal with 3D printing. All right, so we saved the best for last. We're going to tackle this RCA header. I may end up doing other ones also, but let's just see how we go with this one first, because this is going to be really hard. We have to get all these cutouts perfect. We have to get the centers between the RCA connectors absolutely spot on. There's a lot of wires to resolder. Yeah, so we've got to line up 8 of these things. We've got to get all the mounting holes perfect. We've got to recreate this plate, and these Sony jumpers that join the preamp to the power amp have no free play in them, and they bridge between two separate RCA connectors, and they have to slot in like this one here. So if anything is out of whack or slightly out of alignment, this is not going to work. So we have our work cut out for us. The new connectors that I'm going to be using also are hexagonal in regards to how they mount. So that just adds another level of complexity in regards to this thing. Plus we've got a cutout that has to go through the middle for this thing to seat. I want these things to be recessed and held in place so they cannot twist or come loose per usual. So yeah, I'm just going to get started on this, but this is a big one. So yeah, see how we go. Apologies again for not being able to show you how I actually designed this live, because it does take a lot of trial and error and there's a lot of messing around. It's taken many hours and I've finally designed this plate, so I'll take you through it again from the ground up, how I would do the design process. So in the case of this RCA panel, we would start with the base plate. This one is going to be thicker because we're going to be recessing the hexagonal sort of mount for the RCA connectors. We would then add in the mounting holes. Yet again, I've reduced them from 3.5 millimeters down to 3 millimeters for these ones. Got the alignment on these perfect. It took a few iterations to get this right, but we had to add in the cutouts or the recessed areas for the RCA connectors to sit into. These are going to be a press fit. Is going to be quite a tight fit, so these are not going to move around at all. They're also going to be retained on the back with a nut to hold them in place also, but I just don't want them twisting or moving them around at all. And then we add in the center hole, which goes all the way through to the bottom, and this is going to be the threaded portion that goes all the way out the back of the plate. We then mesh it all together and we have the finished result. And yes, I know this looked really easy, possibly, but I can tell you that getting the alignment between all of these, between the sections here and then down to here, because these are a different distance between these two. Getting it all centered, making sure it lines up with the cutouts in the chassis. This was a lot of work, and I cannot believe I actually managed to pull this off. Almost forgot, I thought I would just show everyone Snapmaker Lubin in case you're wondering what the other side of the 3D printing process involves. So this is the model that we've loaded in from Tinkercad, and I have some profiles set up here. We are using Markforged Onyx filament. These are the settings I am currently using. I'm not saying I'm an expert at this. This filament is not designed to run on anything other than a Markforged printer, so I've been adjusting settings as I've been learning how to use this filament. But we basically run the hot end at 275 degrees, the bed temperature at 60 degrees, gets amazing adhesion. So this is what I am using at the moment. In regards to print quality, we're just going to do medium quality print, medium speed, normal model structure. And for anyone who's wondering, here are some of my print settings also in regards to what I am using. I'm generally trying to get the best surface finish possible with the best fine details. I do have ironing enabled, and that's pretty much it. So if anyone who's wondering, Snapmaker Lubin is a slicing software that is built specifically for Snapmaker printers. It also does laser cutting and CNC also. It used to be quite buggy. It's much better these days. It's quite a good piece of software. It still has its flaws, but it's better than your free software that you just download online. So basically we go here and we generate the G code, and we can get a preview of what our print is going to hopefully look like. I always do a brim around the edge, especially with large flat surfaces, to make sure that we get good adhesion and the print doesn't warp or lift, hopefully. This is about a 3-hour print, 5 meters of filament. So we load this to the workspace. This is the other part that's a little odd in regards to how Snapmaker does things, that you got to load it to a separate area, but that's fine. And we're just going to call this rear plate RCA, and that's pretty much it. So my printer is named Artie, so I've just got to connect to it. And I don't know why it has this authorization thing still. It's really annoying. I wish they would just get rid of it. And then I can send it to the printer, and it's ready to go. So I can just disconnect and start the print. And that's just a quick intro into what Snapmaker Lubin is. So here's the finished product. I've tightened everything down just temporarily just to see how it goes. It's all nicely press fit in. Nothing is loose. So I'm just going to put this in the rear chassis and let's see if this thing actually fits. So everything is looking absolutely amazing. The alignment is really good. I did have to do another iteration and move them over about 0.5 millimeter just to get the alignment perfect. The jumpers go in really nicely and seat nice and firmly. I'm really, really happy with how this turned out. I really want to do the entire back now, but I think I am just going to do the input section, which I'll do separately because it's the same as what we've gone through here. I don't think I'll bother with this area. I'll just polish that up. But I wouldn't mind all the inputs to be the same connectors as what we've got down here. I know I said gold plated doesn't matter. I can already hear the comments, so stop typing. I went with the gold plated version of these over nickel because they were 50 cents more per connector. I agree, they look better, but at the end of the day, it's not for sound quality. It's just because I like the look of them and the price wasn't worth worrying about. It's a very different story with binding posts. I can't get gold-plated versions of these ones. Well, I can, but they are full-on binding posts and they are incredibly expensive, so that is why these are not gold-plated. So I hope you enjoyed this video on 3D printing aspects of restoring old amplifiers. I think 3D printing is a really important part of the restoration process these days. They can really get you out of a bind when it comes to making filter capacitors fit in places they weren't designed to go, as capacitors have shrunk as technology has improved. Making new RCA connectors, new speaker binding posts, you know, endless possibilities with 3D printing. And I do sort of work in the industry and I get exposed to a lot of different 3D printer technologies, and hopefully this can help a few people learn how to get themselves out of a bind when they're trying to restore old vintage gear. If you want to see any other 3D printing videos, there's videos in my history on the Artisan on getting this mark forged carbon filament to work. There are other filaments available. You don't have to use mark forged. I just use it because I'm a fan of it. There's eSun carbon filaments, etc. You can get away with PLA filament also, but it is not very heat tolerant and it will deform and warp at not very high temperatures. So it is best if you can learn how to work with carbon type filaments or just filaments in general that have a higher melting point or deflection point. Any questions, put them in the comments. If you want to see further videos on 3D printing processes and things I've learned over the years, let me know. And we are starting to really close in on this amplifier. We've got to rebuild the power amp, power supply, get all the other stuff reinstalled. We're getting close, maybe a couple more parts and this thing will be finished and it will be restored to a point unlike pretty much any other 4650 that's out there, in my opinion. Thanks for watching and I will see you in the next video.